Right now, you're sitting in a pressurized metal tube screaming through the sky at 500 miles per hour. Outside your window, the air is thin enough to kill you in seconds and cold enough to freeze your blood. You're separated from that literal void by a few layers of acrylic. And then you look down and see it, a tiny, intentional hole at the bottom of the glass. In any other vehicle, a hole in the window is a disaster. At 30,000 feet, it feels like a death sentence. But here's the terrifying truth. That tiny hole isn't a flaw. It's the only reason your window doesn't explode. Once you see how this works, you'll never look at a plane the same way again. To understand the hole, you have to understand the invisible hammer hitting your plane. Think of the air inside the cabin like a giant, overinflated balloon. At high altitudes, the pressure inside is pushing outward with nearly 8 pounds of force on every single square inch of the fuselage. That's like having a literal freight train trying to burst out of the walls from every direction. If the windows were just a single sheet of glass, the pressure difference between the cozy cabin and the vacuum-like exterior would shatter them instantly. But we didn't always know how to handle this. In the 1950s, the first commercial jetliners, the de Havilland Comets, started literally disintegrating in mid-air. Engineers were baffled. As it turned out, they had designed the windows with sharp, square corners. Those corners acted as stress concentrators, where the pressure would build up until the metal simply snapped. We learned the hard way that at high speeds and high altitudes, every tiny detail is a matter of life or death. The breather hole was born from that same obsession with survival. But here's the interesting part. Your window isn't actually a single window. It's a 3-layer sandwich. The outer pane, the heavy-duty shield facing the cold. The middle pane, the one with the hole. The scratch pane, the thin plastic you can actually touch. Picture this. The outer and middle panes are the ones doing the heavy lifting. They create a pocket of air in between them called the air gap. The tiny hole, officially called a breather hole, acts like a primary safety valve. Its job is to balance the pressure by allowing the air from the cabin to reach the outer pane. Think of it like a relay race. The hole ensures that the outer pane takes the full brunt of the outside pressure first. This keeps the middle pane in reserve. If that outer shield were ever to crack, the middle pane is right there, already pressurized and ready to take over the load. Without that hole, the pressure would be trapped and uneven, making the entire window structure brittle and prone to blowing out like a popped light bulb. But that's not the full story. Have you ever noticed why the windows don't fog up despite it being minus 60 degrees Celsius outside? That's the second secret job of the hole. It allows moisture to escape from the air gap. Without it, the temperature difference would cause massive frost to build up between the layers, leaving you staring at a wall of ice instead of the clouds. Most people don't know this, but the scratch pane, the one you lean your head against, isn't even structural. You could literally kick it out and the plane wouldn't lose a single PSI of pressure. It's only there to keep your fingers and snacks from scratching the actual safety layers. Also, look closely at the shape. Notice how every window is perfectly round? Following the lessons of the 1950s, those curves allow the pressure to flow smoothly around the opening. If there's one thing engineers hate, it's a sharp corner. In the end, the breather hole is a perfect example of curiosity engineering. It's a tiny, overlooked detail that manages thousands of pounds of force. It's a reminder that in aviation, we don't fight the laws of physics, we negotiate with them. Something as small as a pinprick is the difference between a routine flight and a catastrophic failure.